Dun, dun, dun. Dun, 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 dun. Hi, everybody. Welcome back to Chem 161. I don't know what I'm on anymore. I'm doing a bunch of these videos to do makeup lectures for the campus closure on Wednesday. This is for 161. You'll notice that I have posted in the chat, if you are watching right now for some reason, why are you doing that? That I am not opening the chat for this because I'm just giving a lecture. You can see the chat's gone. Where did it go? It's gone. No. Please direct any questions that you might have to my email, and I will address them or post them in the Discord. However you want to get to that is fine. We're going to do a bunch of practice problems for this and finish off Chapter 1. We'll start Chapter 2 on Tuesday. And at the end of this lecture, once this is posted, I will make the quiz available. The quiz will be available for a week. It'll be only on Unit 1, and you can do whatever it is that you normally do for quizzes. So we've already talked about how quizzes work. So maybe a little bit more of that at the end. During this lecture, I'm not going to pause to give you a chance to do problems. You'll have to hit pause on your own since this will be in post. Once it is done and YouTube has processed it, the video will be available. You can just hit pause, try and do the problems if you want, and then I will immediately, if you're just hitting play, I will immediately go, take a second to do the problems. Welcome back. Here's how you do the problems. It'll sound really stupid, but that's the magic of video editing. So, yeah. That's what we're going to do. We're going to go through the rest of the section. I'm going to do all the problems for you so that you have a record of them being done and can compare your work against them. This is mostly review from 140. We are going to basically do all of whatever Unit 3 was in 140 and a little bit of Unit 2. So feel free to tap through it. Just go straight to the problems if you feel comfortable. Whatever it is that you need to do. And again, let me know if you have any questions later on. Okay. So what we're going to do first is I'm going to take my pen and make sure it works because... there we go. Okay, good. I actually had just tried to record this like 5 minutes ago and my tablet crashed and I had to scrap the recording. So let's get started. I'm going to take this relationship down here. 1 kilogram is equal to 1,000 or 10 to the 3 grams. And what we're going to do is we're going to do math with this. We're going to do a bit of algebra. That's not the pen I want. There we go. Okay. So I'm going to start by doing this. I'm going to write the expression like that. And then I'm going to do some algebra. I'm going to divide both sides by the same thing. And I'm going to divide both sides by this. You're allowed to do that. You can divide by anything as long as it's the same on both sides. Now I'm going to neaten this up. Let's tidy up. Anything divided by itself is just 1. So whether that's a number or a unit, those are both 1. So I get 1 times 1, which is 1. This over here, these don't cancel out, so everything just sticks around. That's not super useful on its own, but stick with me. We're going to do it again. And this time, I'm going to divide by the other side. And the same thing will happen. My 1 divided by 1 is 1. I don't need to cancel those, but kilograms cancel out. And so I get 1 equals this stuff over here. Now what I have is 2 relationships. They both equal 1. Therefore, what must be true is that they equal each other. There we go. Now, why is this important? This is relevant because setting this up as a mathematical relationship allows us to then use these conversion factors to do dimensional analysis. I can trash old units by canceling them out and convert them to new units. Furthermore, I'm always multiplying something by 1 because remember, these equal 1, yeah? And this will be true of any conversion factor that you make. It's just 1. You're multiplying by 1 over and over and over again. So you're not changing the value of whatever you're starting with. You are simply modifying its units and then creating a conversion to get a different value in different units that has the same amount as the initial value and units that you started with. For example, if I had 5 kilograms of something, I could find its mass in grams by multiplying it by this over here, because the kilograms on the bottom would cancel out with the ones in my problem, leaving grams, and then I get an answer that's 1,000 times bigger, because grams are 1,000 times smaller than kilograms. I end up getting the same value. 5 kilograms and 5,000 grams are the same, but the units change. And so we can get different information about something by doing this. Okay. So let me hit clear. And then this will just do the same thing that I was talking about. I called these unity relationships in some text that I had like in, I don't know, the 70s, whatever. Not really. But here's the visual cue of what this allows us to do. Here's my 5 kilogram object. If I multiply it by a conversion factor in such a way that the units cancel, then I get an answer that has different units than what I started with. But the value of the whole thing considered together is the same. So these are the same thing, because I multiplied by 1. Sorry, I had to get something there. Okay. So let's do some examples here. Here's another really simple example that we'll do. So I want to go in here. Oh, I didn't capture the right thing. Whoops, that's a little bit chopped off. Let's make that bigger. I have all the space to work with. I don't have chat, so I might as well use the whole screen, right? Okay. So we're going to do the same thing here, except instead of 5 kilograms, I'll have 6.8. I want to convert kilograms into grams. I'm going to make a little flow chart that's going to help us do our dimensional analysis. I could look up that same relationship. I know that 1 kilogram is equal to 1,000 grams. And so to convert from kilograms to grams, I would set up my units so that I would cancel out kilograms, leaving only grams. So in order to do that, I have to pick one of my relationships. Either the kilograms will go on the top and the grams go on the bottom, or the kilograms go on the bottom and the grams go on the top. Remember, it doesn't matter which way I go. They both equal 1. So I'm going to pick the one that helps me. Well, if I want to cancel out kilograms, I got to put kilograms down here. So I'm going to do this relationship. And then I'll just go and fill in the numbers once I'm done. So now that I've got it set up, let's run the numbers. So kilograms was 1 kilogram, and grams was 10 to the third, or 1,000. And then I can do the math. So that would be the mass of my bowling ball in grams. All right. Now let's do the same thing. We're going to make it in milligrams this time. I already have an answer in grams, so let's turn my answer that's from grams to milligrams. And just like before, we need to look up a relationship. How many grams in how many milligrams? Well, if I look up on the metric table, which we talked about in an earlier lecture, we know that 1 milligram is 10 to the minus 3 grams, or 1,000th of a gram. So we'll set it up the same way. Here's my number that I'm going to start with. I don't want this grams unit anymore. I got to get rid of it. So what do I put on the top? Do I put 10 to the minus 3 grams on top and milligram on bottom? Or do I put milligram on top and 10 to the minus 3 grams on the bottom? Set it up so that the units cancel. So if I do this, I can then turn it into milligrams, and my answer will be in milligrams when I'm done with the calculation. Once all the units are set up, we can do the numbers. Milligrams was 1, grams was 10 to the minus 3. And so now I can do the calculation, punch it in my calculator, and I get this. That's the math part. After all these problems, I forgot to do this at the top. We got to check for sig figs. This number is 2 sig figs. This is a definition, so it is exact. Doesn't affect our sig figs. Our answer should have 2 sig figs. Same thing down here. This also has 2, and this is exact as well. Check your sig figs at the end because all we're doing is multiplication, and you should be in good shape. All right, that's the most basic type of problem that we're going to see. Let's do something a little more advanced. In your textbook, there is a table for metric to imperial units. We're going to do the exact same type of calculation as before, but we're going to use conversions from that table. Or you could just type them in Google. So if you don't know what the conversion is from kilograms to pounds, because I think we're going to do an work in pounds, yeah. If you don't know how many pounds there are in a kilogram, you can look that up. There will be 2 conversions. Let me quickly Google them for you. I have one memorized, but I don't know the other off the top of my head. Let me find that real quick. So here's the first one. Actually, let me put this on a... Hold on just a second. Let me throw this over here so I can see it. So, oops, I drew everywhere. So I have this conversion. And then I also have this conversion. Now, these have different numbers, and I could flip these however I wanted to. So this one could also be kilograms on the top and pounds on the bottom. And this one I could also flip if I wanted to. And that could be pounds on the top and kilograms on the bottom. What's the difference between these 2 units? The answer is there isn't one. It entirely depends on what unit you are turning to. For example, a kilogram is a larger unit than a pound, so turning from pounds to kilograms will give you a smaller number, which is why we have a smaller number here. If I'm going from kilograms to pounds, pounds are a larger number, pounds are a smaller number, so you'll get a larger number of pounds for a kilogram. So that's why there's a bigger number on top there. That is just how the math works out. You'll also notice that for each of these comparisons, one of the numbers is a pound, one of the numbers has a 1 and the other has some other number. The 1 is different for each case. And so these are actually just inverses of each other. If I were to divide 1 divided by 0.4536, I would actually get this number, 2.204. So the takeaway is if you are looking up these conversions and you get a different conversion than, say, another classmate, odds are the 1 is in a different spot. So if you have a 1 with pounds, you'll get a different number than if you have the 1 with kilograms. Oops, I didn't mean to erase that, but I'm going to erase it all anyway. So whichever conversion you get will be correct, whether you have the 1 next to kilograms or 1 next to pounds. And it doesn't matter when you do the calculation because you'll get the same result. Okay? For this specific problem, we're going to start with kilograms. And I want to find the answer in pounds. So I need to go from kilograms to pounds. And so looking up at my relationships, I have on the screen still 1 kilogram equals 2.204 pounds. I'm going to just use that relationship. I could use the 0.4536 pounds equals a kilogram if I wanted to, but 0.4536 kilograms equals a pound if I wanted to. You'd still get the same result. Now we're going to place the units down. Same as before, I want to get rid of these units, so I got to set it up in the same way so that they cancel out. And then I enter in the numbers. So 1 kilogram, 2.204 pounds. And we punch this in the calculator. I think it's 330, but I might as well use the calculator just to be sure. 330.6 Then we're going to check for sig figs. Let me get a different color. This number as written has 2 sig figs. This number as written has 4 sig figs. This right here is an exact quantity. If you ever see 1 in something, remember that's exact. The other is the approximation. So my answer should have 2 sig figs, which means I'm going to report 330 pounds as my answer. There you go. That's how we'll do imperial to metric, or the other way around. Okay. So now I'm going to hit clear, and it's going to do that for me. There we go. All right, so what I want you to do is I'm going to give you some time to do these problems, and I'm going to take a sip of water and be right back. So give me a sec. Pause the video, try these 3 problems, and then we'll go over the answers. Okay, good. I'm glad that you had enough time to do these problems. I'm sure you didn't if you didn't pause. But we're going to go over them now together. All right, so let's capture the first one here. And then we'll clear all of this. All right, so for this problem, I'm given a weight of 579 pounds. And I want to turn from pounds to kilograms. So let's go look up that conversion again. I have that window, it's just hiding. And I know that 1 kilogram is equal to 2.204 pounds. With that information in mind, we can then set up our units. I don't want pounds anymore, so I'm going to cancel it out. That's going to leave me with kilograms. My answers match the units that remain in the problem, and that's what the units of my answer are being asked to be. So now I can do the numbers. Over here, 1 kilogram, we'll do that. 2.204 pounds, we'll do that. Then we'll punch it in our calculator. I need a calculator to be handy. And I get 262 point, let me put this over here actually. 262.704. That's way more sig figs than we need. Now let's check for sig figs. This is 3. Again, whenever you see 1, that's exact. This is 4. My answer should only have 3. And there you go. Okay. Let's do this next one. I travel about 15.5 miles to work. You know, back in the before times when we actually could go to the campus. So I'm starting with miles. Let's write that number down. How far have I gone in kilometers? Okay. I need to look up the relationship between miles and kilometers, so let's do that on Google. 1 mile to kilometers. And the relationship it gives is 1 mile equals 1.609 kilometers. Now, obviously, you can type this into Google and be like, well, okay, if 1 mile is this, give me 15.5. That's kind of not the point. Yeah, Google can solve it for us. I'm showing you how to do the dimensional analysis for simple problems, so you can then apply this to more complex ones. Because the problems I give you, you're not going to be able to put on Google. Trust me, I've looked. All right, same deal as before. I don't want miles, so which of these am I going to put on top and on bottom? Well, I got to cancel, so we're going to set up the miles so that they're like this. That's not what I meant to type. Not type, but write. There we go. Now my units that are left over are the units of my answer. I want an answer in kilometers, so we can run the numbers. 1 mile, 1.609 kilometers. Get your calculator ready. And I have 24.9395 is what it spits out. Let's check for sig figs. This is 3 sig figs. This is 4 sig figs. Ones are exact. My answer should have 3 sig figs. So we'll report it as 24.9 kilometers. Yeah, I don't live very far from work. Here's a more involved conversion. I have a 2-liter bottle of soda. Yeah, that's just 1 sig fig. How do you think they get you with just 1 sig fig? Yeah, your soda could have anywhere between 1.6 and 2.4 liters of soda. 1.5, actually. Because it rounds to 2. Might be a fun experiment to measure, just to see if the soda company is cheating you. Or maybe they're not. Who knows? I don't know. And I want to turn that into gallons. So we're going to start liters to gallons first. And then we'll do the other conversion shortly. So I had to look this one up too, because I don't know how many gallons are in a liter. And what it says is 1 gallon equals 3.78541. I'm just going to do that many liters. I hit the wrong button. There we go. So, same as before. I don't want liters. Let's get rid of it. That'll give me gallons. So I want an equals there. My units check out to be with what I want it to. So I can now do the numbers. 1 gallon, so we'll put 1. 3.785 liters, so we'll put that number here. Match up the numbers with the units. Grab your calculator. 2 divided by that. And I got 0.5284 015, whatever. That's all going to get reduced anyway because this only has 1 sig fig. Number 1 is always exact. And then 3.785 is 4 sig figs. My answer should have 1 sig fig. So a 2-liter bottle is about half a gallon. And you could try and test that. If you have a gallon like milk jug and you wash it out really well, you could dump 2 2-liter bottles of soda in it. You should fill it. Maybe have a little bit more because of this. Okay, now what we got to do is we got to do the other problem. We got to do this in microliters. Oh, I'm going to run out of space here. That's supposed to be a mu. So looking up the metric table, these are both metric to metric. So a microliter is equal to 10 to the minus 6 liters. A microliter is really tiny, so I should end up with lots and lots and lots of microliters for a 2-liter bottle, right? So let's see if that's the case. I don't want liters. I want microliters. So those cancel out. That will be my result in microliters. Now that we've got everything set up, we can run the numbers. 1 microliter 10 to the minus 6 liters. Punching it into the calculator, I don't actually need to do this one. We'll get a giant number. Remember that metric to metric is exact. So my answer should have 1 sig fig, based on the number that I started with. Oh, that's all the problems on that sheet. Okay. All right, so there you go. That's how you do those 3 problems. Hopefully your answers match. If you have any questions, let me know on the Discord or email. The next thing that we're going to consider are for more complex problems. We're going to use this unit map idea that I've been drawing off to the right side here. A hint that I would give you for doing these types of problems is you're always going to start with a constant. So somewhere in a problem is going to be how much of this is in this quantity. Like how many feet are traveled if I drive for 6 hours at 65 miles an hour. And so one of those numbers I said, the number of miles, is a constant. The other one is a conversion, the number of miles per hour. You always want to start with the value that's constant. Don't start with conversions because you need to use the conversion to solve the problem, and you're going to have to flip your conversion in a specific orientation. So for example, if I write down those numbers that I said, so let's suppose I drive 6 miles, and I want to find how long it takes me to drive if I drive 60 miles per hour. If I just happen to multiply them like this, these wouldn't cancel. So what I need to instead do is take my relationship and flip it. Now the units would cancel and I would get a unit of time at the end. Okay, so don't start with this conversion. Start with this constant value instead for the problems. When you see a problem, look for the conversion and then look for the constant. And make sure that you identify which one is which, because you don't want to mix the two up. Okay, and then do what we've been doing all along. Okay, so let's do some examples of these. How many hours are there in 2 years? Like, that's not a direct relationship. You wouldn't look up how many hours are in a year on Google. I mean, you get a giant number. That's not super useful. But we can do this by figuring out what's the constant. Well, there's only one number in this problem, so that's going to be easy to do. That's going to be my starting point. And I can turn years into any number of things. So eventually I want to get to hours. Well, I know how many hours there are in a day. That's a definition, right? And then I do know how many days are in a year. That's a well-established number. So I could do this conversion. Let's write out those conversions on here. So how many hours are in a day? Well, there are 24 hours in one day. That's known. And then how many days are in a year? So in 1 year, there are 365.25 days. Why am I doing 365.25? Well, because a year, a solar year anyway, is not exactly 365 days. A calendar year is. But what if one of those years was a leap year in my 2 years there? I don't actually know that. It's possible. There's a 1 in 4 chance, right, that any of those years is a leap year. So we want to use this number for days to years just because it is more exact. That 0.25 there accommodates the fact that every 4th year we'll have 1 extra day. In reality, every year has about a quarter of an extra day. And then in order to compensate for us skipping over that quarter of a day 4 times, on the 4th year, we have an extra day, and it's February 29th. Now, it goes even further down than that if you're curious. There's things like leap minutes and leap seconds, because, again, it's not exact. 365.25 is not exactly a solar year. There's a small amount of difference between it. But for our purposes and the number of sig figs that we have, this will be fine. So now we're going to set up our units just like before. I want to turn years into something else. Got to cancel it out, so I'll put years down there. On my chart, I have gone from years to days. But days is not the answer. So if I hit enter here and do the calculation, I'll get days. That's not what I want, so let's not do that. Instead, I'll just add another conversion factor. And I'll put days on the bottom to get rid of it. And then we'll put hours on top. And that will give me an answer in hours. So I got my unit set up. Let's run the numbers. How many days are in a year? Well, we already found that out. There are 365.25 days in a year. And then there are 24 hours in a day. So we'll put those numbers down. Make sure you're putting these numbers in the right spot. They don't always end up on the top. They don't always end up on the bottom. It totally depends on the conversion that you make. So just be mindful of that. Punch it all in the calculator. 2.0 times 365.25 times 24. And I got this. 17532. Now, we have to be careful with sig figs on this because some of these are actually exact. So 2 years. This is an approximation. I didn't say exactly 2 years. I said 2.0 because I don't know what the 2 years are. Which one could be a leap year, could not be. So as written, this is only 2 sig figs. This is also an approximation. 1 by itself is always exact. And then this one over here, 1 is exact because, duh, it's got a 1 there. What about this 24 hours, though? Well, we have defined a day to be 24 hours, right? So it turns out that this is just counted. So this is exact too. If you aren't sure whether a conversion is exact or not, see if you are measuring something against something that can be defined. For example, we define a year as 1 trip around the sun. How many days will we have? Well, 1 trip around the sun is not going to have an exact number of human construct things to line up with it. Whereas days and hours are both human constructs. And we've defined a day to be 24 hours specifically. Now, you might not know what's been defined or what's not, because, again, this is an introductory class, so you can always look it up. I will try to tell you which conversions are exact and which ones are not if I use special conversions, like that. So, looking at all of this information, I've got 2 sig figs and 5, so my answer should only have 2 sig figs. So we're going to report this as 18,000 hours. All right, I had to hit clear because a bunch of text is going to appear to do this. There you go. Let's do a different problem. So let's suppose I'm driving my Harley down the highway at this speed. How many minutes does it take to drive 20 miles? So what's my constant and what's my conversion here? So looking at these, I have 75 miles an hour. That converts miles to hours. So this is my conversion. I could also go the other direction. I could convert hours to miles. Either one works. This right here, 20 miles, is just the value that I'm going to start with. So this is the constant that I'm going to use to work with the problem. And that's what I'm going to set up over here. So I'm going to start with 20 miles and begin my problem from there. Now let's write out our unit map. So I'm going to start with miles, and I want to get to minutes. That's my goal. Now, miles is a length, and minutes is a time. These are different dimensions, right? So I need a conversion factor to convert between dimensions because there's no standard for length and time. The thing that relates these two together would be your velocity. How much length is covered in how much time. So I'm going to need my speed here to convert this miles into something else, and that something else is going to be hours. And based on this problem, the conversion that we are given is that I go in 1 hour, I would travel 75 miles. Now that conversion is unique because I could go at any different speed that I want to. I could drive down the highway at 7 miles an hour. I would probably get pulled over for a different reason. But I could do that, and then the problem would give me a different answer if I used that conversion. But specifically what this question is asking is I want to use this value to solve the problem. So we're going to use that as our conversion. Down here, I want to go from hours to minutes. Hours to minutes is a standard conversion. In an hour, there are 60 minutes. We have all that information set up. Now we can do our problem. I don't want this miles here, so I'm going to convert it away. I'm going to turn this into hours because that's what my chart is telling me I've planned out. And I can put in the numbers there, but I'm going to just do the units first. And then hours into minutes. So that those cancel out. And now that I have all the units in place, I can run the numbers. So how many hours and how many miles? So 1 hour, 75 miles. We'll just put the numbers in where they belong based on the relationships we wrote. And then finally down here, 1 hour is 60 minutes. So 60 minutes, 1 hour. We are now set to solve the problem. 20 times 60 divided by 75. And I get 16 minutes. Last thing we gotta do is check for sig figs. This is 3. This is exact because it's just a 1. This is exact because it's just a 1. This is definition, so it's also exact. We've defined an hour is 60 minutes. But what about this? Am I going exactly 75 miles an hour? Or could it be like 74.9 rounded up to 75, but the speedometer that I have on my my motorcycle only goes to the ones place because there's only marks every 10 or whatever. Yeah, you could go part of a mile. You could go 74.4 miles an hour. That's fine. So what that means is that this number that's written must only be 2 sig figs. Okay? Be careful about looking at conversions and considering whether they are exact or measured quantities. Almost universally, they're going to be measured quantities. So what that means is my answer should have 2 sig figs, and I lost my cursor. There it is. So this should have 2 sig figs, and it does, so this is the answer I'd report. It should take me 16 minutes to drive 20 miles. All right, I'm going to hit clear again, and then the stuff will appear on the screen. There you go. All right. This is Scoots. Scoots is a puppy. Scoots eats a lot, as you can see by his food bowl. Scoots eats 65.3 grams of kibble every day, because he's a puppy. Aww. How much will he have eaten in pounds in 35 weeks when he's no longer a puppy? He'll be a big boy. This one I have to put on this screen. Oops, all we got was Scoots there. There he is again. Goodbye, Scoots. And I need to clear this out of here. And scroll up. Oops, that's too far. All right. Looking at our information in the problem, there's two numbers present. There's 65 grams of kibble every day. And then 35 weeks of time is the time frame we're looking at. Which of those is the conversion, and which of those is the starting value? Now you'll notice that I've highlighted a lot of stuff for 65.3 grams of kibble every day. When you see every or per or something like that, that indicates a relationship linking two dimensions together. In this case, we're linking 65.3 grams per day, which is the same as me saying I have this many grams in one day. And so I can make a conversion out of that. I could put either of these on the top or the bottom, however I want. The other piece of information we're given is a time frame. But there's nothing else associated with that. Excuse me. The problem doesn't say he eats X number of pounds in 35 weeks. We're actually trying to solve that. So it's not a conversion. That's just our time frame that we're going to use as our constant. Okay. So if I know the number of weeks that I want to examine, I need to figure out how many pounds he will eat in that time frame. So I need to get from weeks to pounds. This is going to take some finagling with our units, but let's just start with what we know. Pounds is a mass, and weeks is a time. Can I convert my time or my mass to the units that I have in this conversion? Well, sure I can. I know how many days there are in a week, so I could convert weeks to days. And I know how many grams are in a pound because I can look that up on Google. It's like 453 or something, right? And then using this conversion right here, I can convert a number of days into a number of grams. If there were like 17 days, I could figure out how much food he ate in 17 days in grams, right? Just by using that relationship. So let's put that there. Scoots eats 65.3 grams in a day. And then I just had to do these other conversions up here. So in a week, there are 7 days. And in a pound, there are some number of grams. Let me look that up. 1 pound, 2 grams. 453.6. So there are 453.6 grams in a pound. All right, we've got all the information, so now we just got to get from weeks all the way to pounds. So I'm going to turn weeks into days to cancel out my weeks there. I'm then going to turn days into grams to cancel out my days and to get my time unit into a mass unit by following my chart. And then finally, I'm going to turn grams into pounds to get the unit that I wanted to solve the problem. All right, how big of a porker is Scoots? Let's see. So in a week, there are 7 days, because that's what this says here. He eats 65.3 grams per day. And there are 453.6 grams in 1 pound. So how much is he going to eat? That's a lot of food. So Scoots will eat 35.2700 pounds of food in 35 weeks. How many sig figs should I have? Well, this is exact. You look at any calendar, there's always 7 days in a week. These ones are exact. This has 4 sig figs. This is 3 sig figs. Does Scoots eat exactly 65.3 grams per day? Probably not. Those kibble pieces are not uniform. And then finally, 35 weeks. Is this counted or not? That's up for debate, to be honest. Like, I could count 35 lines on my calendar and say, okay, at the end of this, what do we got? Let's assume that it's not counted and just report our answer to 2 sig figs. So this should have 2 sig figs, which means this is how much food he eats, or roughly a pound a week. So if you're buying those like 15-pound bags of dog food, you're going to need to go through about a little more than 2 of them. All right, so that's our puppy problem. So he is now happy, and now he's a big boy. He's still small here, but that's okay. Let's look at another animal. This is Hazel. Hazel was my cat for a long time. She passed away, but she was like 22. So she lived a long life. Now I have Maya and Kresnik, who aren't meowing because they're probably asleep. It's like what? It's 7:15 when I'm recording this PM. Let's suppose that we take Hazel to the vet, and we need to give her aspirin because she sprained her paw because she's just so cute. She's so cute it hurts. It hurts her. That's how cute she is. The recommended dose of aspirin for kittens is 3.67 milligrams of aspirin per kilogram of kitten body weight. How many milligrams should be given to Hazel, who weighs only 2.41 pounds because she's a kitten? Now, Hazel wasn't 2.41 pounds when she was 22, but she was also very small. She only weighed like 9 pounds, maybe 8 pounds. And this actually isn't Hazel. This is just a picture I found on the internet of a calico, but Hazel was a calico. And we loved her. Oh. So let's do this problem. This is the same premise as before, but I just have totally different units to work with. Let's identify what our starting value is and what our conversion is. So I have a mass of aspirin to be given per kilogram of body weight of the cat. What that means is if the cat weighs 1 kilogram, you would give her this much aspirin. If the cat weighed 2 kilograms, you'd give her twice that much, and so on. So that's clearly a relationship. So kilograms. I'm going to be specific here. I'm going to put a little extra info here. Ooh, I gave her way too much medicine. Let's bathe the cat in a vat of aspirin. So this is milligrams. Yeah, be careful about that too. That's really easy to accidentally do. Please do not overdose my cat. You also can't see that. Let me scroll that up a little bit. So that's my conversion, and then the amount that I'm going to start with is her weight. And because I have 2 masses in this, I don't want to mix them up. I'm going to indicate that that is the mass of the cat. So let's go over here. We're going to take pounds of cat, and I want to figure out how many milligrams of medication should be given to Hazel. All right. So I know how many milligrams of medication per kilogram of cat, because that's this conversion right here, right? Can I turn pounds of cat into kilograms of cat? I can, because I need to know what the conversion between pounds and kilograms is. So that's easy. We'll look that up on Google, and I've already done that. 1 kilogram is equal to 2.204 pounds. Whether it's pounds of cat, pounds of aspirin, pounds of soda, pounds of yogurt, cheese. I'm thinking of foods because I'm really hungry. It's dinner time. Doesn't matter. It's all the same. Masses are masses. So I can turn between units of that mass however I want to. This conversion right here depends on the safe dosage recommendations that a veterinary clinic will establish. So this is not a standard. I need to look this up. And so the conversion that I found was 3.67 milligrams of medicine for every 1 kilogram your cat weighs. Okay, let's set up our units. I don't want pounds of cat, so we're going to cancel the cat. I know, that feels weird. Don't cancel your cat. Unless it's Maya. She's not here to hear that, though. Then I cancel her by shooing her out of the room or squirting her with the spray bottle. I can only pick her up and put her outside so often. I'm talking about my cat and getting confused. So, all right, we're going to go from pounds of cat to kilograms of cat. So we're going to do kilograms of cat. And then for the next unit, I'm going to turn kilograms of cat into milligrams of medicine. Oh, we're going to cancel the cat again. Sorry, Maya. And then this will be milligrams of medicine. All right, let's do the numbers. A 1 kilogram cat would have a weight of 2.204 pounds. And I would give a 1 kilogram cat 3.67 milligrams of medicine. So for my cat that has a different weight than 1 kilogram, this would be the calculation to figure out to determine how much to give her. I'm punching it in my calculator. That's the wrong button. What I got was 4.0130. We'll just do that. Milligrams of medication. Let's go assess sig figs. We don't want to overdose the cat. This is 3 sig figs. This is 4 sig figs. 1 is exact. 1 is exact. And this is 3 sig figs. The lowest number of those is 3, so I should have 3 sig figs in my answer. So we would give Hazel 4.01 milligrams of medication based on these guidelines. Just a comment right here. This 1 right here, the reason that this 1 is exact is because we have established the medication standard against a standard cat that weighs exactly 1 kilogram. Now, obviously, the standard cat doesn't exist because that's not a very healthy weight for a cat, 1 kilogram. But theoretically, this is the observed amount that we would use. Oh, I'm sorry. I put the 1 in the wrong. I put the arrow in the wrong spot. It's this one. This conversion, the 1 is standard because it's pounds to kilograms. All right, there's our Hazel. Bye, Hazel. See you next time we do this problem. Here's a troll. I wrote this slide when I was playing Dragon Quest XI. I want to answer these questions down here at the bottom. This is why we care about the troll. The troll appears to weigh 825 pounds. How much does he weigh in milligrams? And then I have other questions to answer here. We're going to go over these in just a second. I'm going to give you a chance to do them. How long in minutes would it take to travel 36.5 miles at a speed of 81.3 kilometers an hour? And then if salt costs $10 per pound, how much would it cost to buy 15 kilograms of salt? We're going to do all these problems in just a second. So go ahead and pause and give them a shot. And you can wonder if I actually defeated this troll. Yes, I did. This is a long time ago. I haven't played this game for a while. Welcome back. I'm glad that you had a chance to do the problems. That was like 2 seconds for me. So we're going to go over here. I'm just going to leave all the problems on the screen. That's fine. We don't need to see the troll. He's not essential to the problem. He's just there for flavor, I guess. Okay, so for this first problem, I'm going to travel 81.3 kilometers per hour. And I need to travel 36.5 miles. So my starting quantity is miles. And I need to find out how long it will take me to go that far in minutes. We did just do a problem just like this. So I need to get to these units so I can convert from a distance or length to a time. So if I do miles to kilometers, I could figure out my distance in kilometers. I could also figure out my time in hours. That would turn that into minutes. And then I know how to get from kilometers per hour because I can use the speed that's listed here. So let's write down my conversions. We'll start with the speed. So I can go 81.3 kilometers in 1 hour. In an hour, there are 60 minutes. And then finally up here, how many miles are in a kilometer? I've already forgotten. I think it's like 1 mile. 1.609 kilometers. You know, let me go look that up. I don't want to mess this up. 1 mile, 2 kilometers. 1.609. Okay, cool. We'll set up the problem just like before. I don't want miles. It's gone. Cancel, cancel. According to my chart, I'm going from miles to kilometers, so that's what goes up here. Then I'm going to go from kilometers to hours. Canceling out my kilometers. And then finally, I'm going to go from hours to minutes. Canceling out my hours. The problem asked me to solve for how many minutes it would take. Minutes are the only unit left once I've set them all up like this, so let's do the numbers. 1 mile, 1.609 kilometers, so I'm going to enter those in. 1 mile, 1.609 kilometers. 81.3 kilometers in 1 hour, so 81.3 kilometers per hour. I'm just matching them up. That's all you got to do. And then 1 hour is 60 minutes. 1 hour, 60 minutes. Type it all in. 36.5, 1.609 times 1 times 60 divided by 81.3, 43.342. That's enough sig figs, right? Let's check for sig figs. This is 3, because that's not an exact distance. It's just how far I'm going to go. 1s are exact. You know that by now. This right here is approximate, because in exactly 1 mile, there are about this many kilometers. This is also approximate, because I'm not going exactly 81.3 kilometers per hour. Could be a little bit less, could be a little bit more. It'll round to that. My speedometer is not that exact. This is exact because these two things together are a definition. So looking at those, 3 is the lowest. My answer should have 3 sig figs. Let's round it to 3 sig figs. There you go. All set. You pause that to write it down. I hope you paused it because now it's going away. All right. Salt costs $10 a pound. I think that's actually like grossly expensive. 1 pound of salt. How much would I pay for 15 kilograms of salt? All right, let's map out our units. This is my conversion. This is my starting value. So I want to turn my starting value, kilograms of salt, into money. How much will I pay? It's my Scrooge McDuck bag. Here, we'll even put like a, I don't know. There you go. That's a bag. Actually, it looks more like a bong. Maybe I'll just erase that. Oh, it's already on the air. Whatever, right? Okay. How the heck do I get from kilograms of something, which is a mass, to money, which is a value? Well, I have a conversion up here for money to pounds, so if I could figure out how to get from pounds, or from this to pounds of salt, I could then convert it to money. Well, kilograms to pounds is very easy. We've done that several times today. 1 kilogram of anything equals 2.204 pounds of anything. And then I have $10 per pound. I'm being specific on this problem because it's just a good habit to get into. It's not necessary because we don't have 2 masses like we did with Hazel's problem. All right, let's follow the chart. I'm going to turn kilograms into pounds. Kilograms of salt. Pounds of salt. Cancel out the salt. And then I'm going to turn pounds of salt into money. We'll cancel out the salt there too. I'm not on Twitch, so I can't really cancel the salt, I guess, but that's all right. Our result will be money. Let's fill in the numbers. 1 kilogram is 2.204 pounds, so 1 kilogram, 2.204 pounds. And then it's $10 per 1 pound of salt based on that. Punch it in the calculator. What do you get? I get $330.60. Now, it might make sense to say, oh, well, cents are discrete. I should keep all the way down to the tenths place, right? So, or the hundredths place, so I know how many cents I'm paying. But in reality, things can cost fractional cents, right? You might see gasoline cost $2.74.9 per gallon, right? They have that 9/10 at the end, so they can cheese you out of just a little bit more money. I don't know. It's just formality. This is just what we do with gas as a commodity. To put it on the sign. Now, in reality, we do that because if you buy a ton of gallons, that 0.9 of a cent actually matters. If you buy 1,000 gallons, then that's 0.9 of a cent times 1,000, which is actually a significant amount of money. So we do care about decimals of cents, but the important point to consider here is that wherever our sig figs end up, that's where we're going to report to, whether it ends up here or further down or whatever. Okay, so this is 3 sig figs. Exact. This is 4 sig figs. And the money as written is also 4 sig figs. So our answer is only going to have 3. And so the answer I would report is $330. That's what it would cost me to buy that much salt at that rate. If I were you, I would get a better deal. But you know, I'm not the one who is selling or buying. I'm just the one who made up this problem. All right, copy that down. Oh, and it's gone. This is the fun of me recording. I get to tease you because you can always just pause and go back. All right, so I have a troll. Let's draw our troll. So he's got horns. There he is. And he weighs 825.0 pounds. He's big. He needs to go on a diet. Or maybe he doesn't. I don't know. How much does he weigh in milligrams? So we got pounds and we want milligrams. This is pretty straightforward. But how you get from pounds to milligrams might differ. So I'm going to propose one way to do this. Because it's all mass, I don't need any weird conversions. So what I'm going to do, I'm going to turn pounds into kilograms. Because I want to get to metric as soon as possible. And then I can get from kilograms to milligrams somehow. Whenever you have 2 units with a prefix, you should always go through the base unit. So don't look up a conversion from kilograms to milligrams, because no such conversion is easy to commit to memory. Okay? Don't do that. Instead, go to the base unit and use the conversions that we've committed to memory for the metric table. That's a lot easier and a lot more reliable. Okay? I'm doing this in the wrong color. Let's be consistent. I can't hit the button. There we go. We know that a kilogram is 10 to the 3 grams. And we know that a milligram is 10 to the minus 3 grams. So I'll just set up those conversions however I need to get it to the right spot. And then pounds to kilograms, again, we know. That's just from the previous problem. All right, so we'll take our troll here. And we'll turn his mass from pounds into kilograms. And then we'll turn our mass from kilograms into grams, like that. And then finally, grams into milligrams. So now that I have all the units set up, I can then do the numbers. 2.204 pounds per kilogram, 2.204 pounds per kilogram. 1 kilogram is 1,000 grams, so 1 kilogram is 1,000 grams. And then 1 milligram is 10 to the minus 3 grams, so 1 milligram, 10 to the minus 3 grams. Again, make sure you're putting your numbers in the right spot. And as long as you do that and punch it in the calculator correctly, you are all set. I'm going to need more space. 374,319,419.2. That's obviously way too many sig figs. There's no way we know all of that information based on the 4 that we have up here. This is also 4. This and all of these are exact because these are definitions. And this is a lonely 1. So our answer should have 4 sig figs. Oops, there we go. And I'm going to do this in scientific notation. So 1, 2, 3, 4, 5, 6, 7, 8. 10 to the 8. 3.743 times 10 to the 8 milligrams. If you want to insult a troll, tell them their mass in milligrams. I assure you that you will promptly be pounded into a paste. But you know, you only live once, right? What do we got after that? Let's see here. Oh, I have the temperature conversions. This is my favorite little joke that I like to do. This has audio, so we got to turn this up here. All right. This is just a little bit of a blurb to end the chapter with. Actually, I think there might be density problems after this. Let me just check really quickly. No, this is the last thing. Okay. Honestly, doing the temperature conversions back and forth is kind of silly because this is something I would tell you to do on Google because this is such a trivial exercise. And typically, you're not going to turn temperature into like a mass or something like that. You're going to input temperature in a formula and need to know its value in a specific unit. The specific units that you're going to want to use are Celsius and Kelvin. Fahrenheit is common enough. We use Fahrenheit to confuse Canadians. Let me just put these 3 on the screen so you can see them. That's about all Fahrenheit is good for. I can tell my friend in Canada, hey, it was really hot today. Oh, how hot was it? Oh, it was like 84. And he'll be like, holy shit. That's awful, because he's thinking in Celsius like a rational person would, right? 84 Celsius would be almost boiling. Like, you would literally die if it was that hot out. Likewise, he'll tell me that, oh, it was very warm today. It was like 27. And I'll be like, huh? Because I think in Fahrenheit because I'm American and dumb. And I try to think in Celsius, and it's hard because this is what we've grown up with. So we don't want to use Fahrenheit in the laboratory for a specific reason. And that specific reason is that Kelvin is actually very important. We're going to talk more about Kelvin in 162 when we talk about gas laws, where temperature is actually relevant, and also thermodynamics, where thermo and temperature, duh. But the gimmick about Kelvin is that there is a 0 point on a scale for temperature. And for Kelvin, that's actually 0. This is called absolute 0. What absolute 0 is the absence of molecular motion. Temperature is actually defined as the average velocity of molecules in a sample, specifically a gaseous sample, and how fast they're moving, how much kinetic energy they have. At 0 Kelvin, they have 0 kinetic energy, and therefore aren't moving, because a moving object has kinetic energy, right? That is the theoretical lowest temperature. Now, it's impossible to actually get there, because you can't completely stop a molecule, because you would have to completely insulate it from the universe, which has kinetic energy. And that kinetic energy transfers as heat into any medium that you have. So we can't actually get to absolute zero, but we can actually get very, very, very close to it. Now, that value on the Celsius scale is something like this. And with Fahrenheit, it's like minus 454. Those numbers are weird. We don't really want to commit them to memory. But absolute zero provides us a useful reference here. Particularly because we have scaled Celsius in a very specific way. You might notice that these numbers that I'm highlighting are kind of similar. There are the same number of increments between absolute zero and the freezing point of water on both scales. And that's not a coincidence. We've actually defined this to be the same. 1 Celsius is the same as 1 Kelvin. Now, for Fahrenheit, it's a little bit different. 1.8 Fahrenheit is the same as 1 Celsius. These conversions are exact. Just FYI, if you were curious. And you can see that when you look at the difference between the boiling point of water and the melting point of water. There's 180 degrees here, but here there's only 100. With Kelvin, it's the same thing. There's also only 100 because, again, 1 Celsius and 1 Kelvin are the same thing. So this is how our scales are set up. Now, why is Celsius more useful for us? Because it revolves around water, and we've set the freezing point of water as 0, and the boiling point is 100. 0 and 100 are easier to remember than 32 and 212. I often forget the boiling point of water. I remember the freezing point of water because when I used to ride my motorcycle to work, I'd check the weather, and if it was below 32, I would grumble. You should not ride a motorcycle on ice. It's not fun. I did it for 10 years. Would not recommend. Now, the Celsius and Kelvin scales are going to be important later on, particularly Kelvin, because we have set the 0 point as this virtually unattainable thing. Now, let's suppose I had an equation that involved temperature, and there is one. It's this. We're going to use the ideal gas law in 162. I'm going to rearrange this to solve for n, just arbitrarily. And then what I'm going to do is I'm going to input a number for temperature. And let's suppose I was doing an experiment that involved the freezing point of water. What would happen if I did this calculation and tried to put it in my calculator? Well, obviously, it would explode. It's gone, right? That would ruin everything. We've destroyed the universe. Everything is gone forever because we divided by 0. Don't do that. So we cannot use this value. This is not okay. You cannot enter a Celsius value into this equation because 0 Celsius is an actual temperature we can work with. This is a reasonable temperature to do an experiment for a given circumstance. But the number would not work because we can't divide by 0. So instead what we have to do is we have to enter a number in Kelvin. So for temperature conversions that we might end up dividing by temperature with, we need to use Kelvin. So the Kelvin scale becomes very important for that. Generally speaking, if you only used Kelvin in every calculation in chemistry, you'd be safe. There are some that involve Celsius that you can do. For example, delta T, like a change in temperature. The change in temperature in Celsius or Kelvin would be the same because, again, these are the same. So if I wanted this change, doesn't matter where I get, I'm going to get the same number either way. So it's safe to do that. But working in Kelvin is the safest action that you can do for temperature in this class and any other chemistry or physics class you can do. Now, there is an analog to the Celsius scale, or I'm sorry, the Kelvin scale for Fahrenheit. There's this extra scale here. So if this is absolute 0 in Kelvin, this is also absolute 0. But you might notice that I haven't assigned it a letter. I'm going to let you choose the letter. Maybe you can give it a letter. What letter should you pick? Yes, I am putting this on the air. Have you chosen a letter to go there? What could this scale be called? The correct answer is not what you were thinking. It's actually called Rankin. So this is called the Rankin scale. And what Rankin does is it sets the 0 point for Rankin at absolute 0. And then so this would be, since this is, oops, I lost my pen again. Since this is minus 454 or so, the freezing point of water then is positive 454 degrees Rankine. And then this would be whatever that is plus 180. I can't be bothered. The joke was just to get you to try and put the letter U here. So anyway, those are the 4 temperature scales. You're never going to use Rankine. Like, I only put it here just for this joke. We're going to try not to use Fahrenheit because it's stupid. We're going to primarily use these 2. And of these 2, the best one by far is Kelvin. All right. The next few slides have conversions. You could type these in to Google and just be like, what is 27.9 Celsius in Fahrenheit? And it'll do that for you. You don't actually need to use these formulas. The only comment I do want to make is that all of the numbers in Fahrenheit to Celsius are exact. Because remember, the gradations between the two are defined. 1.8 Celsius equals... Oh, I messed up. Hold on. I don't know what I'm talking about. 1.8 Fahrenheit equals 1 Celsius. And also, neither of these are set at absolute 0. We just arbitrarily picked a starting point for both of them, and that was the freezing point of water. So, at the freezing point, (32 Fahrenheit and 0 degrees Celsius are the same thing. So, this is for each temperature, and then this is just at that temperature. These 2 values are set to be the same. A little bit of trivia. This actually came up on Who Wants to Be a Millionaire. These 2 temperatures are actually the same. So you can impress your friends at trivia night whenever you go out. Be like, oh yeah, I took Wes's 161 class. He had that stupid joke about temperature to get us to try and put expletives in our slides. What an ass. Yeah, whatever. And then these are the formulas that relate these two. So you can convert between them however you want to. And if you put 40 Celsius in here, you actually will get negative 40 Celsius in there. You'll get negative 40 Fahrenheit out. That's just an interesting little tidbit. This right here is inexact because the 0 point for Kelvin is set to a physical phenomenon that is theoretical, and the 0 point for Celsius is set to something arbitrary that we just chose. So those don't measure together exactly. There are more digits here that will keep going. So if you use this as a conversion, you would only get to the hundredths place in your Kelvin. Google will do that automatically and just spit out a ton of numbers. So be careful. So if you put like this into Google and it spit out something in Kelvin, you would only get to the ones place of Kelvin. Like, let me type that in. So Celsius to Kelvin. I'm going to put in 32, and it gave me 305.15, but I could only write this. Whereas if I had done this instead, then I would actually get to keep those digits. Okay? And the reason that I'm keeping down to this place and not saying, oh, there's 4 here, so I should keep 4 here, is remember, we're doing addition. So be careful about your operations. Make sure you're applying the correct rules for sig figs. Addition only cares about places. So I go to whatever place that I input. That will be the same as the output. I have a bunch of... we already talked about absolute 0. Again, we'll talk about that 162. I have a bunch of practice problems for you to do for temperature. I mean, you could type these into Google yourself. I'm just going to do that and give you the... Oops, I can't do Kelvin. I have to actually type the number in here. So here are the answers that you should get. I need Fahrenheit for that. So 47 Celsius is the same as 117 Fahrenheit. Because again, going to the ones place. And then negative 11 to Celsius. Oh, that's the wrong one. Negative 24. generally speaking, if you are worried about sig figs for these types of problems, if you go overboard on sig figs, then you don't really have to worry about it. And the reason for that is because... Oh, oops. Tried to convert that and it messed me up there. The reason for that is because temperature is probably not going to... Oops, 212. Temperature is probably not going to be your limiting factor for sig figs anyway. So as long as you put enough digits in there in the input, when you convert it and you copy them all out in the output, something else will limit it. It'll be fine. Not super worried about temperature. I just kind of wanted to talk about it so that you'd have it available. All right. I think that's it for chapter 1. Yeah, that's the last slide. Hooray. Okay, so I have my summary here. You can read the summary all you want. These are the topics that we covered in Unit 1. You're going to want to make sure that you understand all of these... I don't know why it's flickering. All of these topics for the quiz, because I'm going to test you on these concepts. And that's it. That's really all there is to it. For your quiz on Unit 1, you're going to have 30 minutes to answer all the questions. I don't know how many questions there are. Let me look that up. Everybody always asks me how many questions there are. And I always want to be snarky and say, like, oh, there's 2 questions. And then they go, oh, that's so few questions. I'm like, oh, I'm sorry, that was a mistake. There are 20,000 questions. And then they go, oh, because that's a lot of questions. So the quiz is 25 points. I'm just clicking on it to see how many questions are in here. There are 12 questions, and I gave you 45 minutes to do it. Let's see here. The questions will be in a random order. Your answers will get shuffled. You get 1 question at a time, and you can't backtrack. So be careful about answering a question, but also mind your time. Remember, you do get 2 attempts. There's a car alarm going off outside. You get 2 attempts to do the quiz. Your better of your 2 scores is kept. When you are finished with the quiz, you don't get a score. You will just get a notification that says, hey, you did it. The quiz is over. Once you are satisfied with your attempt on either on attempt 1 or attempt 2, that's it. Just leave the quiz alone. When the quiz is due and the deadline passes, I then go in and hit a button, and then you can see all of your answers and all of your scores for your attempts. I think it shows you both. It might only show you the best one. I'm not certain on that. I get to see both of your scores, so I assume it keeps both of your scores because that information is available. You are allowed to use any resource that you want to for the quiz. The only requirements that I forbid are you can't use me. So I cannot answer any questions until the quiz is submitted for everybody. And then the other restriction that I impose on that is just this time limit. So you're going to have a fixed amount of time to answer the questions. If you go looking for answers elsewhere, which you're allowed to do, you're allowed to look in your book, you're allowed to look on the internet, you're allowed to ask other people. I'm not going to restrict you on that because, frankly, I can't. This is an online class. But what I can do is I can limit the amount of time you have. If you don't know how to do these problems and then you go hunting for the answers later, you're going to run out of time. So be really careful that you approach the quiz with the mindset of, okay, I am prepared to a level that I could answer whatever questions are thrown at me, and they're going to be similar to the homework problems in the online text. Some other gimmicks that come up about the quizzes. Your problems are different from other students, so you will not get the exact same problems. Don't just pass over an answer to another person, because I guarantee it'll be wrong. Actually, look at the problem and talk about it. Again, that's going to eat up time. So if you have a dimensional analysis problem and the other person has one similar to that, you're going to have to do some communication of how do you do this, and that's okay. I don't mind if you teach each other, but keep in mind, once you start the quiz, the timer keeps going. And don't rely on the exact different. What am I saying? Don't rely on the exact same problems to appear. So one person might have the Hazel problem, and then another person might have the Scoots problem. There's a pool of problems that I say, This is a topic I want to test you on. Pull one of these problems from my pool, and everybody gets assigned random stuff. So you may have similar problems to other students, but you might not. You might have the Scoots problem. Your friend might have the Hazel problem. Another friend might have a totally different pet. Maybe it's Quacks the owl, and we want to see how many Tootsie Rolls he eats. Or you guys are too young for that. You won't remember that commercial. Whatever. But the point is, don't rely on other people. Rely on yourself. That's the best way to ace the quizzes. And the quizzes aren't that difficult if you're prepared. You can do it. Okay? That's all I got. So I'm going to put this up. I'm going to get the little music out. And I'm going to call it a night here. I'm going to go make Swedish meatballs or something. I don't know. So have a wonderful whatever time it is whenever you are watching this. And we'll see you for the next lecture, whenever that might be. Cheers.